Today we will be looking at trigonometry. So in 6.4, the objective is to use trigonometric ratios to solve for side lengths, and angle measures in right triangles. So let's take a look here. You guys have talked about SOHCAHTOA before in algebra, but just to review, so SOHCAHTOA, the S stands for sine, and so sine equals the opposite over the hypotenuse, hence the SOH. The cosine equals adjacent over hypotenuse, hence the CAH. Tangent equals opposite over adjacent, TOA. So SOHCAHTOA. And so for the sides, you're going to use the sine, cosine, and tangent. And to solve for an angle, you're going to use the inverse, which on your calculators you can hit second sine, and it'll give you the inverse sine with that little -1. So let's do a little practice. Let's first identify the three sides in relationship to angle K. So if we're looking here at angle K, we have, so here if we're looking at angle K, the side right next to K is going to be our adjacent. The side opposite our K, so across, is our opposite. And then you guys have worked on identifying hypotenuses, so our 13 is our hypotenuse. Here again, identify the three sides in relationship to angle J. Here, our 12 is going to be our adjacent because it is touching our angle. 5 is the side across from that angle, so that's our opposite. And then 13 is still our hypotenuse. So why do we not do trigonometry functions in relationship to angle L? That's because in this case, angle L is our right angle, and we would end up having two adjacent sides. So we'd have an adjacent because they're both touching angle L, and then we'd have our hypotenuse yet. So we don't have an opposite side, so that does not work. All right, let's solve for H. So if we're standing here, so we're standing here on the 38. Some of you learned to draw your little people there. Then this is our adjacent. This is our opposite. And 15 here is our hypotenuse. So I'm going to write out SOHCAHTOA. All right, so I'm looking for my opposite. So I'm going to underline my opposite. And I have my hypotenuse. So I'm going to underline my hypotenuse. Here you can see that sine has both of them underlined. So we're going to choose sine. So you always set this up. Then sine of our angle. So the angle, the degrees, always goes inside of there. Okay, so when you're first setting it up, always write sine of your angle equals, and then here our O comes first, so that equals our opposite, which we said was our H, over our hypotenuse, which is 15. So then we can solve for H by multiplying by 15 on both sides. So that cancels our 15s over here. And we get that H is 15 sine of 38. So we can type that straight into our calculators and get H to equal 9.23. So be following along with that. Try some on your own. So here again, you can see that we had sine of our A equals our opposite over our hypotenuse. And we got sine of 38 equals H over 15, multiply by 15. Again, you get approximately 9.235. All right, try this one. We're standing there. We have our adjacent, our hypotenuse. This is our opposite. So write out your SOHCAHTOA. So adjacent hypotenuse, we're going to choose cosine. So we're going to get our cosine of 49 equals your adjacent, your x, over your hypotenuse is 23. Multiply by 23 on both sides to cancel that out. And we get x to be 23 cosine of 49, which we solve x to be then 15.09. So again, here you can see we have our x to be 15.09. All right, now we want to solve for our angle. So we're still going to say that we're standing here at the angle that we're looking for. And then note here that the triangle is rotated. So actually, if you take a look here, we rotate it to be sitting on its bottom. Our 24 is going to be our hypotenuse. So I'm going to rotate it back quick. But let's just note here then that this is our hypotenuse, and then this is our opposite and our adjacent. So writing out SOHCAHTOA, we have our opposite and our hypotenuse, so we're going to use sine. So let's call this angle right here x. So I'm going to say sine, and then here I'm going to put in my angle, but the angle is what we're looking for, so I'm going to write an x, and that equals our opposite over our hypotenuse. Now, to solve for x, that's where we use the inverse of sine. So we're going to get x equals the inverse of sine, and we put our 12 over 24 then in our inverse function. Like I said, you can hit second sine in your calculator and then put 12 divided by 24. So we get our angle to be 30 degrees. And one note in this, make sure that you're in degrees in your mode when doing all of these. If you're in radians, it'll be off. Alright, so again here you can see we took the inverse sine there of our 12 over 24 to get 30. Alright, here we have our angle 38. We have our hypotenuse is what we're looking for. We're given our opposite and we don't have our adjacent. So we have SOHCAHTOA. Note that I'm writing this out every single time. Alright, so opposite and hypotenuse are the things that I have or I'm looking for. So I'm going to use sine. So I'm going to say that the sine of 38 equals my opposite, my 15, over my hypotenuse, z. Now note here, if I multiply by z, it cancels out on that side, but then I still have z sine of 38 equals 15. So then, from there, I have to divide by the sine of 38 on both sides. So it cancels out there. So I'm going to get that z equals 15 divided by the sine of 38. So if I type that in, I get 15 divided by the sine of 38. I'm going to get 24.36. So that's the length of my hypotenuse. So note here, they multiplied and divided. So just a quick note that when you have sine of some angle, so we'll just stick with our 38 equals 15 over z. A lot of times I'll just draw these arrows and swap those two. So I'll say that 15 over sine of 38. Swapping those two, I'll get that. Alright, again here now we're looking for our angle. So let's call that our angle x. This note here is our 90-degree angle. So across from that is our hypotenuse. And then across from our angle here is our opposite. So again, SOHCAHTOA. I have my hypotenuse and my opposite, so I'm going to use sine. So I get sine of x equals my opposite over my hypotenuse. We already did this one, but just, I guess, go through it again. Sine of our inverse, 12 over 24. we'll get our 30 degrees, which we went through. All right, so here we're standing at our 55. So you're always going to stand at the angle that it's given to you. You're never going to stand at the 90-degree angle. So here's your adjacent, here's your opposite. I'm going to write out my SOHCAHTOA. I have my adjacent and my opposite, so that's tangent. And so I'm going to get the tangent of 55 equals my opposite over my adjacent, multiply by 43 on both sides. To cancel that out, I get y equals 43 tangent of 55. So I'm going to get y to be 61.41. So just note there, we get 61.41. All right, solving for w. If we're standing at our 38, we have our adjacent. We're looking for our hypotenuse. Write out my SOHCAHTOA. So adjacent and hypotenuse, I have cosine of 38 equals my adjacent 15 over my hypotenuse w. Note here, I'm going to draw my arrows and switch those. So I'm going to get w to equal the 15 divided by the cosine of 38. So I get w to be 15 divided by cosine 38 is 19.035. So here again, you can see the work. All right, I'm looking for my angle. So I have my adjacent and I have my opposite. So write out my SOHCAHTOA. My opposite and adjacent, I have the tangent of my x is going to equal my 9 over my 21. So then I'm going to take the inverse of my tangent of 9 over 21. And that's going to give me my angle to be 23.199 degrees. So approximately 23 degrees there. All right, thanks for listening. Good luck.